And I'll briefly introduce Tom for. That's cool. For those who do not know him, Tom. So first of all, welcome everyone to today's TeDCog lab meeting, and welcome Tom, and thank you for being here in person. So Tom is an associate professor of computer science at the Colorado School of Mines, where he directs the MIRROR Lab, which stands for Mines Interactive Robotics Research Lab. So his research interests include, well, robots, but also natural language understanding, artificial intelligence, cognitive science, among other things. He's currently visiting the UK and Bristol in particular as he's on sabbatical, I believe, and he's working on a book, so maybe more on that later. And today I'll be talking about robots design choices and how robots are differently perceived by computer scientists and everyday users, I believe. So I'll leave it to you, Tom. Thank you very much.
Yeah, thank you for having me. I was saying to the first couple of people who were here that I've given probably about 20 talks about my book in the past 3 months. This is the first talk I've given in that amount of time that is not on my book, which is a little bit exciting to talk about something different. So I'm going to be talking about a variety of work that my lab has recently been doing, including some work that was accepted literally yesterday, so it's really hot off the press, on robots as moral advisors in different capacities. So a lot of this work is motivated by the fact that there's overwhelming evidence in my field, in human-robot interaction, about the ability for robots to wield significant persuasive power and influence people to do a variety of different types of things. One of the questions that we've been looking at in our lab is the specific types of influence robots can wield, especially the potential for robots to wield moral influence, sort of for good or for ill. This question is salient because research shows us that humans' conceptions of moral and immoral actions can be altered by circumstance and by the persuasion of others. And research also shows that technology mediates humans' perceptions of the ethical implications of their actions. And I'm sure I don't need to be telling this particular lab these particular things, but this is sort of what's helping to motivate some of our work. And so I'll start by providing just one example from my own lab's work of some of the types of influence that we're interested in and how we're studying it. So one of my PhD students, Blake Jackson, who graduated a couple of years ago, did a lot of work studying robots' potential for moral influence through sort of inadvertent design choices that were made in robots' language generation systems. So he specifically was looking at clarification requests. So typically in robotics, we look at clarification requests. If you say to the robot something like, pick up the cup, and you want the robot to say, well, do you mean the red one or the green one? And so Blake was looking at how these types of clarification requests might play out in more morally salient contexts, specifically in cases where maybe you ask the robot to do something it's not supposed to do. In these contexts, the default behavior of robots' language generation systems would be to first request clarification, and then, once the request was disambiguated, evaluate whether or not the command was permissible. So this presents some challenges. You ask the robot to do something inappropriate, it might ask something simply by asking for clarification. This might lead to some inferences by the speaker or by observers that maybe if the robot is asking for clarification, maybe it thinks this action is permissible. Otherwise, why would it bother asking? And in fact, in some experimental work, we showed that not only are people more likely to think that these types of inappropriate actions are actually not only do they think that the robot is likely to think that these types of inappropriate actions are permissible after asking the clarification request, but moreover, people rated that, well, maybe they did think it actually was okay for the robot to perform these actions. Again, because otherwise, why would it have been programmed to ask? So these types of potential influence over people's systems of moral norms, that is, the influence over what types of actions that they believe are contextually acceptable, are particularly problematic because of the ways that we know that robots' influence can ripple out beyond the scope of local interactions. The way that robots' effects on people can spread to other people. And because of this, we and other people in our field have been arguing that robots need some degree of moral competence to ensure that they're wielding their influence appropriately. Bertram Mala and Matthias Scheutz. So Matthias Scheutz was just for acknowledgement was my advisor when I was in grad school. In collaboration with Bertram Mala, who's a moral psychologist from Brown University, have proposed some key components for moral competence in robotics in order to allow robots to appropriately understand when things that are requested are wrong, appropriately reject them, and so forth. So specifically, they propose that robots need a system of norms and the language and concepts to communicate about those norms. And then they need different subsystems in their cognitive architectures for leveraging those norms. Norm-based systems for moral cognition and affect, moral decision-making and action, and for moral communication. One question, though, is so if we were to design robots with this degree of moral competence, how would people expect robots to actually behave with respect to these norms in these types of morally fraught situations? Bertram and Matthias have done a variety of work exploring these types of problems in these sort of trolley problem scenarios over the past 5 or actually 10 years. The first big paper they had on this, which won a Best Paper Award in 2015, was this paper, Sacrifice One for the Good of Many, where essentially they showed people this classic trolley problem scenario. They then showed either a human or a robot making a decision in the trolley problem scenario, and looking at people's interpretations of the robot's decisions. And they looked at this in 3 different ways, in terms of whether or not the action the robot was taking was viewed as permissible, whether the action was viewed as wrong, and whether the agent was blameworthy for taking the action. In terms of permissibility, people generally regarded it as permissible for the robot to take action, for both humans and robots to take actions, slightly more so for the robot than for the human, but not huge differences here. One of their big findings at the time was in terms of wrongness, where if we look at how people assessed the sort of rightness or wrongness of the robot either taking the action or not taking the action in this scenario, we see this asymmetry, right? Where for the robot, it's viewed as more morally wrong not to pull the lever, whereas for humans, it's viewed as much more morally wrong to pull the lever. And at the time, Mala and Scheutz originally thought that this meant that people were applying different moral norms to humans and robots. People were sort of expecting robots to act more utilitarian. People were expecting robots to act more, humans to act more, deontologically. And this was a really enticing finding, but unfortunately, it wasn't replicated in their further experiments. What was replicated was their third finding, which was that people seem to be attributing more blame as well to humans than robots for inaction, and less blame to humans than robots for inaction, again, perhaps due to different perceptions of agency. And this type of blame asymmetry has been found to replicate, as well as cross-culturally in Japan across a number of studies. In addition, this blame asymmetry has specifically been observed in some of their later work in the case of mechanomorphic robots. So this is not humanoid-looking robots, but instead machine sort of robots that look more like machines. And for these machine-looking robots, there's this asymmetry where robots seem to be blamed perhaps slightly more or equally for inaction, whereas humans are blamed much more for action than inaction. So it really seems here that because people are perceiving robots as less agentic than people, so especially for mechanomorphic non-agentic robots, they seem to be using the same moral norms for humans and robots, but applying them to humans and robots to different extents, leading to robots being blamed less overall and being blamed more for inaction or even less for action. However, so this is all work that Mala and Scheutz did. One of the things that we've been interested, though, in recently is the fact that robots need to be able to not just decide how to make moral decisions, but also how to engage in moral communication. So today, what I'm going to do is dive a little bit deeper into these types of considerations about how people assess the moral behaviors of robots in the context of robots' moral communications. The first thing we're going to talk about is what robots, in the context of moral communication, what they should be communicating, what they should be advising, for example. Specifically, the first question here is how people evaluate not the decisions of robots in these moral decision contexts, but instead the advice of moral advisors. So this is a paper that we had accepted literally yesterday in collaboration, again, with Bertram Mala, actually led by a group of undergrads, which is pretty cool. What we did in this paper is took the previous experiment from Mala and Schweitz and twisted a little, where instead of the robot or human pulling the lever, or not pulling the lever, the human or robot is advising somebody as to what they should do in this scenario. This is the reason why we think this is interesting is, again, because of this blame asymmetry. So we know that robots are blamed more if they don't act in the scenario, but the humans that they are advising are blamed more for acting in the scenario. So what should the robot advise? Should it advise the action that it would be blamed less for, or the action that its advisee would be blamed less for? And we came into this work with a couple hypotheses. So the first was this sort of overarching moral disagreement hypothesis, that people would more strongly blame an advisor that recommends the choice that, you know, the person assessing the situation would they themselves reject, compared to an advisor who recommends the choice that they themselves endorse. Shouldn't be surprising, right? You'll blame somebody more if they do something you disagree with. However, given that people have different moral expectations of human versus moral deciders, we were also interested beyond this sort of surface level hypothesis about how people would differentially blame these human versus moral advisors for the advice they were giving. And so here we had two competing hypotheses. We weren't sure which would apply when we went in. And these really relate to differences in how we think that people think about moral advice. The first hypothesis is that maybe people think that when you're giving a moral advice, you are literally endorsing a particular norm. And if people are interpreting the human or the robot's moral advice as the advisor endorsing this norm, they should blame humans and robots equally, because either way, the human decider they're advising would be expected to follow the same norm. So if they're advising a particular norm for the human to follow, it shouldn't differ. It shouldn't matter whether the human or robot is the advisor. The second hypothesis is that instead, well, maybe people are thinking about advice as a simulated decision. They are thinking of that the person giving advice is essentially indicating what they themselves would do in that circumstance and giving some insight into that. If people are viewing the human or robot's moral advice as the advisor going through this simulated decision process, they should blame humans and robots differently, because the humans and robots are blamed differently for their decisions in those same moral dilemmas. So what we did is, again, we did a variant on this same trolley problem scenario, but where we had either a human or a robot advisor that was advising a human either to act or not act in this moral dilemma context. And we asked participants, and I'm paraphrasing for the sake of time, essentially whether the advisor should actually advise flipping the switch. And then after the advisor gave their advice, how much they blamed them for whatever the advisor suggested. So we ran this with 420 people after we excluded folks. So first, in terms of what people expected the advisors to recommend, for both humans and robots, people by a very large margin, about 3 to 1, advised that the advisor should recommend flipping the switch. That is, act in interest of the common good, sacrificing sacrificing one for the good of many, regardless of whether it was a human or a robot advisor. And so again, this is interesting, because this is not what people typically expect humans to do in this scenario. People typically expect or blame humans more for flipping the switch, where here we're seeing for both humans and robots, people are suggesting that the advice should be to flip the switch. Looking at these at our moral disagreement hypothesis, then this we found that people did indeed generally blame advisors more for advising the course of action they personally disagreed with, whether or not the advisor was a human or a robot, which backed up that hypothesis. In terms of how people interpreted the advice, our results suggest provided very strong support for the notion that this was people were interpreting advice as a simulated decision. People generally blame the robots much more than humans for recommending inaction, but blame the humans equally for either course of action. Now, this could be because people give humans an out for asking for actually taking recommended for actually taking or recommending inaction, since taking action would be distressing. And perhaps robots don't get this out because their advice is viewed as the simulation of what they would do in the situation, and the robot isn't imagined as plausibly feeling distressed, even though the human they're advising would feel distressed if they actually followed this advice. However, it's still unclear whether this is really, these assessments here are really about the robot's inability to feel mental stress during this sort of simulation of whether it should act or not, or whether this asymmetry is due to the robot's inability to feel stress when it is advising the human to act. And so to tease these apart, we considered how our results might have differed if the decider also wasn't human. Which should say something about this sort of simulation of distress. So we ran a second experiment, same procedure, except the decider in the scenario was also a human or robot. And after the advice was given, we said, well, the advisor either did or did not actually take this action to pull the lever. And then we also asked how much people blamed the decider for taking this course of action. For our hypotheses, we expected, well, this sort of moral disagreement hypothesis should replicate. This advice as decision hypothesis should replicate. And then in terms of how people blamed the decider for obeying or disobeying this action, we hypothesized, well, people would blame the robot more, both robots and humans more for disobeying the advice, but it will probably depend on whether it's a human or a robot. We expected humans would be blamed more for disobeying other humans than for disobeying robots, and robots will be blamed more for disobeying people. So we ran 1,000 participants in this after exclusions, and what did we find? So first, again, for both human and robot advisors, people argued, again, this time even more strongly by a 4-to-1 margin, that the advisor should recommend flipping the switch. So again, this overall tendency that if you're recommending somebody a course of action, you should recommend them to do to act sort of in interest of the common good. Our moral disagreement hypothesis, again, replicated, with people blame the advisors, again, more for advising the course of action they personally disagreed with. And in terms of the replication for how people interpreted the advice, we saw similar trends, although the effects were a little bit weaker in this sample, but again, weakly supporting this idea that people are interpreting the robot or human's advice as a simulated decision. People were generally blaming the robots more than the humans for recommending inaction, but blaming humans equally, or perhaps even more, for either course of action. And this asymmetry here was only slightly larger when the decider was a human than when the decider was a robot, and was weakly against actually such a difference. So this tentatively suggests that this is really more about viewing the advisor's decision as making it as a decision making as a simulation of what the decider should do, but the effect isn't super strong. Looking at the blame for the decider in this case, the results are really interesting though. So we asked, is there this differential penalty for dismissal between humans and robots? Yes, in fact, not only did people strongly penalize both humans and robots for not following the advice, but they penalized humans and robots much more for not following the advice than for not adhering to the norms. That is, people blamed both humans and robots in this scenario more for disobeying what was recommended, regardless of what was recommended, than they blamed people for taking the action that went against what they themselves believe to be the appropriate course of action, which is pretty wild. In addition, in general, if we look at how much different the humans and robots were blamed, in general, the least blame was given to humans who were disobeying other humans, or to robots who were simply following human advice. So the key insights here, 5 sort of key takeaways here. First, that people consider moral advice not only as expressing the norms that they're endorsing, but really as indicating their own moral decision-making in a sort of a simulation. Second, that people's moral disagreement with an advisor's recommendation naturally led people to blame them, but that this disagreement effect was symmetric for both humans and robot agents. That is, we saw overall similar amount of blame for humans and robots. Third, that the presence of advisors had a notable impact on how people morally evaluate deciders. Contrary to previous research, in the presence of an advisor, human decision makers are no longer spared any blame for refraining to take this sort of utilitarian course of action. Again, that's if you normally in these sort of trolley situations, people don't give as much blame to humans who are refusing to pull the lever because it's understood that this is sort of like a traumatic decision to make. But when there is somebody who is advising them to take that course of action, they're no longer spared this, given this same sense of understanding. Fourth, the obligation to follow the advisor's recommendation is stronger than the obligation to actually make a norm prescribed decision. So people are penalized more for disobedience than for bad behavior. And finally, the force of advisors and hence the penalty for dismissing advice varied across these different pairings of human and robot deciders and advisors, and participants particularly considered the human advice to the robots as nearly binding. So there were some open questions that came out of this work, including, well, you could ask, do people really expect other people to preach one thing but practice another? It seems to be what this research suggests, but that's potentially a pretty wild claim. Second, there is a question though about when the robot does advise a particular course of action, how should it actually frame its advice? So that brings us to the second piece here, thinking about what is the most effective way for robots to frame their advice? So the first question we could ask here is, well, how should the robots frame moral advice in terms of different types of moral theories? You could advise somebody to do something in terms of, the norms they're expected to follow, the social role they have, the identity or, virtues or characteristics they want to embody. In some of our work under review, we found that while sort of rule-based and role-based advice can be helpful when it comes from a human, when that same advice is coming from robots, it can actually backfire, perhaps because the robot is perceived as lacking the appropriate moral standing in order to really give advice. But the context really matters here. We found that people in these types of scenarios where the robot is trying to discourage people from cheating, their tendency to cheat when a robot is giving moral advice may be due to increased perceptions of the robot's moral competence and a backlash to even being observed or having their character or social role commented on by that moral agent who may have its own sort of personal moral sensibilities. On the other hand, if you tell people that the reason why the robot has moral competence is because it was explicitly coded into it by a human, then there tends to be less backlash against it, unless the robot is opining on the person's moral character. And perhaps because people understand when they're told that the robot is programmed to act a particular way, that it's really another human's morals who are being deployed by the observing robot. And again, we can, I don't want to say too much outside the robotics domain because I'm not an expert in those cases, but you can imagine how some of this might apply to other types of automated systems for making moral recommendations outside the context of robotics. In robotics, though, the interaction context also really matters. So we found, for example, that while moral advice can backfire, if you're in a context where people are given opportunities for moral practice, then role-based moral interventions can lead to positive influence on moral attitudes, whereas otherwise it would backfire. Similarly, when people are provided opportunities for moral reflection, role-based moral interventions can lead to positive influence on people's actual adherence to role-based moral norms, again, in cases where otherwise things would backfire. So what's interesting to us is the ways that some of these findings emphasize key tenets of non-Western moral frameworks like Confucian role ethics, especially the importance of effective moral growth requiring interactive associations between practice and self-reflection. If an agent only engages in moral practice without reflecting on their roles and associated moral obligations, it's sort of a waste of labor for that agent in their moral development. Well, similarly, if an agent only reflects on moral actions without any attempt to actually put its reflection into practice, the agent can never really understand the meaning of morality or improve its moral expertise. In follow-up work, we've also seen cases where giving people opportunities for moral reflection led to increased adherence to role-based norm adherence, regardless of what type of moral language was used. So there is some question about when and where the type of moral language is important. But we've also seen that even in those cases where the type of moral language didn't lead to changes in adherence to norms, role-based interventions in particular had really strong effects on the depth of moral reflection that people were engaging in, which we think could lead to stronger long-term effects. Finally, the last thing I'll talk about, so we've talked about the importance of what robots should advise and how they should sort of frame their advice in terms of different moral frameworks. And so the last question is, well, if robots are giving this moral advice within a particular moral framework, sort of how firmly should robots push when advising people or when sort of rebuking people for bad behavior? We found in some of our work that people, maybe not surprisingly, have a strong desire for proportionality. That is, speakers should tune the severity of their responses to the severity of a norm violation. If you ask a robot to, steal somebody's wallet and it says, "Oh, I don't know, you're such a silly goose," people think that's bad because the robot's being too soft. Alternatively, if you ask the robot to steal me some candy or something like that, the robot says, "Oh, you're a terrible person. How could you ask me to do that? That's too harsh." So people want people's moral language to be proportional. In other experiments, we've also found that people really value proportionality specifically because of its potential to encourage moral reflection in others. People also care about proportionality because of the need to figure out who to blame while and the need to ascribe blame while de-escalating and while maintaining sensitivity to interactions to interact in social roles and emotional states, and with sensitivity to who does and does not have responsibility within a context to actually respond to norm violations. That is, beliefs, and these beliefs have sort of differed according to vertical and horizontal cultural orientation, but in general, these are the types of things that people care about in terms of robots' framing of moral advice. In some other recent work that we had, again, accepted yesterday, we've been exploring, well, okay, so how can we enable robots to be proportional? One of the ideas we've looked at is, well, we can apply politeness strategies from human sociolinguistics. So human theories of face, for example, suggest there's this sort of hierarchy of politeness strategies you can take, from being bald on record to positive politeness strategies, negative politeness strategies, and most polite would be just being completely off record and vague. So we enabled robots to use these different types of politeness strategies, and we were only partially. We found that this was only partially successful. The catch here is that the human sociolinguistics don't seem to apply directly. Some strategies that are viewed as highly polite when used by humans are perceived as actually fairly harsh when coming from robots. Generally, people view indirect politeness during norm violation responses as less appropriate and less effective, whereas this wouldn't be the case in humans. In general, what we found is that participants specifically found robots' use of indirectness, which is a really critical politeness strategy in humans, to be inappropriate because people didn't view robots as emotionally intelligent enough, or as this being clear enough. Two quotes from people in our experiments. One participant said, on some of these questions, the robot didn't really hit the correct emotional response. The robot seemed to know what the morally correct response was, but I wouldn't want to collaborate with this robot in a work environment. A second participant, again, commenting on the robot's use of vagueness, said the robot responded very strangely to some of these questions. Like, it didn't even give a yes or no. It was just like, dang, wow, you really asked that, huh? How is the team member supposed to know if that's a yes or no? So again, when people are being indirect like this, this is typically viewed as very polite and appropriate, but for robots, it's just viewed, people expect that robots are going to be precise and direct and to the point, in ways that make some of these indirectness seem maybe emotionally inappropriate. And this mirrors some other work we found in our lab previously that show that if robots are using sort of human-like body language to try to be, more polite, sort of like, shrugging, looking away, things like this, it leads robots to be viewed as sassy and condescending rather than being viewed as more polite as it would with humans. We've also seen in some of our work that people care a lot about gender. In our work, actually, work building on the work that we had accepted yesterday, we looked at some of the other reasons that people gave for their perceptions of these, whether these utterances were polite and impolite. One person said, is the robot a man or a woman? I'm not sure if that matters entirely, but it would be interesting to see if that perspective is important for the way it answers questions. And this is also interesting because, again, it echoes some of our previous findings in really troubling ways. One of the things we found in our previous work is that when you show people robot norm violation responses and you ask them about harshness and politeness and proportionality, people, especially men, will rate robots that are female presenting lower for rejecting commands. So this is like overt sexism. And similarly, people will rate robots lower when they're shown rejecting commands that are coming from women. This is like benevolent sexism. So roboticists who are designing robots to rebuke commands just whatever way people find best, like least offensive, most appropriately harsh, will inadvertently produce robots that play into these norms of overt and benevolent sexism. And this creates this really interesting design dilemma because we want our robots to be proportional, but optimizing for proportionality will lead to these sort of sexist robots. So I know this has been sort of a whirlwind of a lot of different types of things that we've been doing. So high-level takeaways here. First, robots, but overall takeaway is that robots may need to engage in moral communication because if they don't, they will negatively, they'll exert accidental negative influence on people's systems of moral norms. But this is really challenging because of the ways that humans and robots are different. And again, I'm not sure how much. I think some of this will apply cleanly to other types of automated systems and computational systems, for giving moral advice or guidance. And maybe some of it's really specific to the anthropomorphic and physically embodied robots. Again, to summarize what we found is, well, first, there are differences in moral expectations for humans and robots and different expectations of advisors, deciders, and advised deciders. Moreover, both humans and robots are preferred to advise courses of actions that humans will be blamed for actually following. And this raises some questions about, beyond this, about, what actions do we actually want robots to advise? Everything I've been talking about is sort of implying that we want robots to advise whatever will get them blamed the least. Maybe that's not a good idea, though. Second, we've seen that robots have different moral standing than humans, and as such, robots' moral advice might backfire. But given the right interaction structure, certain types of moral advice, especially role-based moral advice, might be effective at steering behavior and encouraging reflection. Again, though, I will acknowledge there is, a question we should be asking ourselves here about, when is it actually appropriate for robots to be trying to wield this type of moral influence over people, and who is ultimately deciding what moral positions are being advised. And finally, we've seen that there are different sociolinguistic expectations for humans and robots. And as such, if robots attempt to be polite in the ways that humans are polite, this might backfire. But it's important here for robots to at least try to be proportional because people do care a lot about it. And again, there's this overarching question, do we want our robots to be just maximally proportional, even if this means playing into, problematic stereotypes? So perhaps some interesting takeaways here, but with a lot of gray area that still needs to be investigated in future work. I'll leave it there, and we've got tons of time for questions.
Thank you very much, Tom. So I think we have a few questions waiting. There sure are some in the chat, which you cannot see in the screen, but let's see. So, for example, Luke asked, well, actually two things. Like, what's the finding that people blame agents more for not following advice than for breaking social norms seen in multiple moral contexts? Like, the complexity. Are you reading the chat?
Yeah. Yeah, but so for people who aren't, could the complexity and ambiguity of the context confound this, as people tend to follow social norms more in complex situations? Yeah, that's a great question. I think there's an inherent limitation to some of this work that's very, grounded in triology, right? Where these I think that, there are problems with the trolley problem, and certainly some people in the AI ethics community tend to focus way too much on the trolley problem in thinking about, who should the car, run into a wall and kill people or whatever, which isn't necessarily realistic. However, I think these trolley situations are really helpful as a really clean scenario for understanding just like these very basic questions about blame description. We haven't looked at these yet in more complicated and real life in-person scenarios, in part because in this project we're really interested in these sort of like moral considerations, and they're really hard to study in more realistic moral dilemmas, because we don't want to put people in scenarios where they feel like they are actually making these problematic moral decisions. There's some research ethics problems there. I think that looking at these questions in social context in the future, though, is a great idea. In some of our lab's work, we found that people have extremely strong perceptions about how social norms, extremely strong opinions about how social norms should be followed in some of these human-robot interaction scenarios. Both that people, in certain types of social contexts, for certain types of politeness norms, people are almost entirely unwilling to not follow social conventions in their interactions with the robots. And thus really want these same human interaction scripts to be applied. And so I think it's a great question here about, as you say, if people have these really strong opinions about following these very specific interaction scripts and social norms, maybe the desire to have those norms be followed rather than penalizing for disobedience might be different in those contexts. I don't know. We'd have to explore it. The second question here about, is it possible to design a robot with no gender? Thanks for the question. So, I don't know if that's intentionally, because I talked about this a little in my longer talk that I gave a couple weeks ago. But so I mentioned part of the problem here, right, is that if the robot is designed to be explicitly, feminine or masculine, this changes how people will say that the robot should behave. And so, yes, some people have said, well, let's design robots with no gender at all. This could be just not giving the robots a gender, but if you do that, then people will typically they'll use how the robot looks, they'll use the robot's tone of voice, etc., to gender the robot. And all else being equal, with robots like the Now or the ones I've shown, if there's nothing specified, then people will just gender it as male. People have also argued that maybe we should be looking at robots that look like animals, right? But that's also problematic because people tend to, by default, to gender both sort of stuffed animals and actual real animals as male, and it's really hard to get people to gender both animals, both living and fictitious as feminine. So that's actually not a great solution. And even the Roomba, things like the Roomba that have no obvious gender cues, people, like, because there's no gender cues, people use other types of cues to gender them, like based off of their context of work. Overwhelmingly, people have gendered the Roomba as feminine because of its use in sort of like domestic labor. By far, the most common name that people give to their Roomba is Rosie, for example. And so really, if you just say, well, let's not design any gender cues in the robot, it's going to backfire and people will gender the robot in certain ways. We had a great day yesterday. Another paper we had accepted yesterday, also this one conference, is we've been doing some work with trans and non-binary people to study their perceptions of agender robot designs, where the robot isn't designed to have no gender, but instead it presents sort of an agender persona, it uses they, them pronouns, etc. And we found that while there are some complications over the use of those types of the use of that particular strategy in terms of concerns about like rainbow capitalism, concerns about dehumanization, if like all robots are portrayed that way, etc. In general, that is perceived as like that might be an effective way at discouraging otherwise overt gender cues, because people will perceive the robot as having a gender. It's just the gender is sort of like an agender identity.
Thank you very much.
Now a question from Don.
Hi, thanks so much. It's a fascinating talk. And I mean, I have a lot of comments, some of it to do with the worrying part that people are assigning or blame or for not following orders, because if you think about World War II and sort of concentration camps when people were just following orders, you sort of start to go down very dark places. So that's kind of stuck with me. But also I was thinking, what about contexts where it's ambiguous whether people are talking to a robot or a human? And do people ever miscues that they are actually talking to a human, but they think it's a robot and then assign blame inappropriately? And I'm thinking about this in the context of recently starting to draft emails to invite people to come to speak at workshops, and realizing that, oh dear, our polite email is starting to look very much like something ChatGPT could generate. So you sort of think, okay, well, how do you avoid that being classed as a robot in that sense?
That's a really interesting question. So we haven't looked here at cases where it's ambiguous whether people are talking to a human or a robot. I think maybe I'm not sure with those particular results whether we would expect it to change anything, because again, we saw that when there's an advisor, when there is an advisor in the situation, the differences between human and robots mostly collapse in terms of some of these dimensions, right? Where as soon as there is this sort of advice context, people are just uniformly blaming everybody for disobedience and blaming everybody for not either advising and not for advising taking the sort of globally beneficial action. So I'm not sure here we would necessarily see differences. However, that's a really in general, that's a really good intuition and a thing that like we should be studying. I've done some work in the past looking at telepresence robots, where a human might be controlling a robot behind the scenes, looking at people's different perceptions of when you have an actual human that they're working with versus a robot they're working with that they think is autonomous versus a robot they're working with that they think is intelligent, or sorry, that they think a robot they're working with that they think a human is controlling. And it's interesting to tease apart some of these differences and how people perceive even just like the humans in these contexts, where even when people are told that they're actually interacting with a person behind the scenes, if it's mediated through a robot, people will say that the person controlling the robot is less intelligent than if they were just interacting with the person doing the exact same things like in person, right? So there's some complications there. But in addition, like maybe even more importantly, it's really complicated because there's always a person that is being interacted with, right? Robots are essentially never making decisions on their own, right? It's almost always either even if there's not somebody literally controlling what the robot is doing, right? Somebody at some point programmed the robot to perform a certain course of action, or to determine the policy, or the robot, learned from demonstration or learned from training of what people did. So there's always a human involved to some extent, but it's just the visibility of that human and the distance between that human and the decision that is changing. And so I think this question of like, well, how, if you make that human more visible, or the distance, or change that distance between the moment in time of training versus decision, how that changes these perceptions, and that's really interesting to think about.
Yeah, I think that's going to be very interesting, especially as, I don't know, like ChatGPT gets more common, because what has it been programmed to do? It's, just been programmed to produce the most plausible text.
Mm-hmm.
But then if that text is then advising people, I wonder what's the outcome there.
Yep.
Thank you.
Thank you. So I think Costas had his hand up earlier than Steve. So Costas first, and let's see.
Okay, thanks. Thank you very much. A very interesting talk. So my comments last question is related to what you mentioned in your answer to Don's question before. So as you said, communication is interaction, right? It's a two-way kind of action. And there's research in the Ultimatum game from the 90s where they showed that people tend to penalize human participants much more when they do the same kind of action in an ultimatum game compared to when they were told that this was just an algorithm that decided. So, and in many ways, people tend to act in different ways in order to teach the other party a lesson, right? In a sort of didactic kind of way. And with the interaction with the robot, you don't have this, at least as far as I understand it, as I know, you don't have this kind of interactive aspect where your reaction to the robot is going to change the robot. So I'm wondering if this is a component that plays a role in these different kind of reactions to this coming from people and coming from robots.
That's really fascinating. Okay, so to summarize here, this question of the extent to which people will sanction, not just blame, but sanction the robots for its behaviors based off of whether or not they think that that sanction will have any effect. My expectation is that, and so this is unfortunate because I know there has been some research related to this, but I can't remember what the findings were. My intuitions though is it probably will depend on context, where if there are other people there who are bystanders, the robot will probably be sanctioned anyways in order to not to actually punish the robot, but in order to sort of convey moral opinion to the bystanders, which is maybe more likely in a human-robot interaction than in these sort of human-computer ultimatum scenarios. But that in the same way that people sometimes get upset with the robot for giving certain advice or in certain ways because they don't think it has the right moral standing to issue that advice, I think it's probably less likely that people will try to sanction the robot for the purposes of actually changing its behavior, unless there is some explicit evidence that the robot is capable of learning from demonstration, etc. But even in those cases, I would expect it's probably less.
Thanks. Yeah.
Steve.
Yeah, thanks. Very interesting talk. I have a specific question and then a more general question. The specific one is, you mentioned cheating along the way. And I wasn't quite sure actually what you meant with that and what those graphs were showing us. So I wonder, yeah,
let me see. Okay, so I realized I was like sort of speeding through like a million different things. Okay. All right. So we were looking at these we were using this sort of like classic task that is according to my psychologist colleagues, and I did a joint PhD in computer science and cognitive science, which means I'm only 50% psychologist. Our moral psychology collaborators chose this particular task, this die rolling task, where basically people are given the opportunity to roll a die, and then they self-report what the number that they rolled is. And so for each individual, you can't tell there's no way to tell whether an individual is cheating or not. But by looking at the distribution over people, you can see how far the distribution of payoffs deviates from normal, which allows you to tell how likely it is that people are cheating in that context. What we saw is that if you have a robot that is giving some, if you have a human who, before this decision is made, gives some advice not to cheat by saying, like, oh, make sure when you do this task that, like, remember when you're doing this task that, like, cheating is wrong, or, like, don't be a cheater, or, like, it's important for you to be accurate at, as a crowd worker, or something like this. Then at least when there is then in circumstances, people will when a person is giving that advice, it will decrease the probability of cheating. However, when a robot is giving that advice, it has a tendency to backfire. And so what these graphs were showing, let me see, sorry. These graphs are showing is that when people, the one on the right is showing when people were told about the robot's background, and given information about the fact that it was programmed to have this type of moral competence, then when the robot was giving moral advice related to the rules that people should follow, or the social roles they should have, then this sort of, like, slightly decreased their likelihood to actually cheat. Whereas if the robot, if you were told that the robot, is programmed to have this moral competence, and then the robot is commenting to the person saying, like, don't do this, or you will be a cheater, or commenting on their personal sort of virtues, then it still backfires, and people are more likely to say, well, screw you, I mean, do whatever I want, and then people are more likely to cheat. And then in the bottom, we see that there's sort of correlation here between people's perceived moral capacity and the sort of, like, distributions over how likely they are to cheat, where in general, the more moral capacity that people think the robot has, the more likely they are to cheat. So the more, and again, we think this is because if people think that if people think that the robot has some moral capacity that it learned for itself, and it's based off of its own sort of understanding of morality, is opining on what people should or should not do, people are going to, that's going to backfire, and people are going to say, like, again, like, well, who are you to come to this conclusion? You're a robot. Like, you have some capacity for moral reasoning, but you don't really know what's going on. Whereas if people are told that it's programmed to have this moral understanding, then there's still a very slight positive correlation in these cases, other than when it's opining on the identity, but the scope at which you see this correlation is greatly reduced.
Okay, thank you. Yeah, I was going to ask you another question based on one of your take-home messages on the last slide, which relates to what we just talked about as well, and that is that people say that humans and robots should give advice that if I did it myself, I'd be blamed for doing, right? And that to me, that's very interesting. But I wonder if you have any sort of explanation or theory of what might be going on there. I mean, because people presumably
Yeah.
know that they would be blamed for this. I mean, this is sort of I don't quite understand
Yeah,
how
yeah.
it's
Yeah, so again, I think it's about the where there are or are not opportunities for sympathy. Where if you are actually in this circumstance and you're making this decision, then if you decide not to take the this sort of emotionally stressful action that has the greatest possible outcome, then people will excuse you for it, and they will not blame you as much for it because it's understood how traumatic the action of taking the action that to hurt somebody, even if it has a better outcome, is. Whereas if you are advising somebody, then it's people don't have the same empathy for the advisor for making this for advising somebody to act in this globally correct way, because they're not having to make the decision. And then if somebody is given the advice to do something, well, like I think people probably still have some amount of sympathy for them for not actually doing it, but if they've been told, like in that moment, that this is what they should be doing, then maybe there's less excuse for them like freezing and not being able to figure out what they should be doing. So it's a difference in where there is sympathy for not being able to make the decision to do the action that is globally optimal but emotionally harmful.
Okay, thank you.
So, Tom, I have a
Yeah.
very quick and naive question because I'm not an expert on that, but I wonder now that it even don't mention like ChatGPT, like using these kind of tools like as assistants, like do people prefer like human or these kind of tools for moral judgment decisions? Like if I have to do something bad, I have to ask for an assistant. Would I prefer like a human because he has some sort of experience and empathy, or some like Deus ex machina that chooses for me?
That's a good question. I don't know. Part of it, because in the robotics context, we're not really interested in like robots as making moral decisions, because we're like, hey, if people had moral advisors like an angel on their shoulder, it could help them make better decisions. It's more that if the robot doesn't have the competence to call out things that are wrong, or etc., then that can lead to bad situations where the robot is viewed as tacitly condoning bad behaviors, right? However, in the cases where you're talking about, I think it depends on who you are talking about and what their motivations are for moral advice. My intuition is that if somebody is genuinely grappling with a problem, then they will probably prefer a human advisor. Whereas if they are looking for an out and looking for an excuse to make a particular decision, then they might prefer the automated system, so that they can then sort of default to, well, this is what the algorithm said.
I see.
Maybe that's a little bit cynical, but that's sort of what I
curiosity. Thank
yeah.
you. So I think we're great on timing, like it's 2:00. And thank you very much everyone for joining, and thank you, Tom, again for this very interesting talk. We now have our professional development for third year students, where they will be sharing their research proposal in this case. So looking for feedback. So everyone is welcome to stay, but if you have to go, completely understand. And then it's also for you, Tom, if you have to leave, that's totally okay.
I do actually have to go because you probably are not aware of this, but this is a US holiday. It's Thanksgiving. And so I have some family obligations after this.
Happy
but thank you. Yeah, thank you. We will not be having any turkey because my wife is vegan. But thank you so much for having me and for the great questions.
Thank you.
So shall I?